So we're going to start at example 1. By the way, on the front page, these formulas that we've already talked about a bunch of times are there. They are part of section 1.3 as well. It's just section 1.3 now. We're going to talk about real-life application of lines. So if you need formulas, they are there. Then what I did was to save a little bit of time is I already went through using the slope formula, and I already went through using point slope formula to find the equation. I did the stuff that we've already learned, and we're just going to interpret it. We're going to talk about how it's a real-life application now. So anytime you're doing a real-life application, there's going to be information in this picture that's very useful. So right here, this asteroid, and if you read the directions, it'll talk about, this is an asteroid from 2012. Its name is DA14 that's traveling. So at the bottom, the x-axis says time in seconds. The y-axis says distance in miles. So what's 524 mean?
5 seconds, 24.
So after 5 seconds, the asteroid has traveled 24 miles. Okay? So now what we're going to do is we're going to interpret the slope.
Why are you doing something?
I have a difficult.
All right, ready.
Okay. Keon.
Yeah.
You're going to need to watch the video. You might need to. Can you please stop throwing things? Did you throw it too?
Okay, no. But listen.
No, we don't have time for that. Bye.
You know what?
Okay, back to this. So you guys are telling me that this asteroid traveled 24 miles in 5. I wrote minutes, by the way. It's not minutes. I know. I read it wrong, and then I wrote it wrong. There we go. So you're telling me it traveled 24 miles in 5 seconds. What we're going to do is we're going to kind of simplify that, and you're going to interpret the slope so you can tell me how fast the asteroid travels per second. So anytime we're doing slope, the slope is always the difference of y over the difference of x. And this Greek letter D is like a triangle. It means the change or the difference in y over the difference of x. So when we look at this here, we're going to first talk about the y's. We're going to talk about the miles. Then we're going to talk about seconds. We talk about miles per second. So what we need to do is we need to figure out that the asteroid travels how many miles per second. So we have to find it per 1 second. So how do I take 24 over 5 and change that so it is per 1 second? How do I do that? You divide it. 24 divided by 5. 4.8 miles per second. So that is interpreting the slope. If we need to interpret the y-intercept, the y-intercept is this plus b at the end of the y equals mx plus b equation, or on the picture, if there's a picture, it'd be where it crosses the y-axis. What does that mean for this situation?
0 seconds, there's 0 miles.
At 0 seconds, I wouldn't say there is 0 miles. I would say it's traveled 0 miles, because that's what we're talking about, is like how far an asteroid travels. Asteroid traveled 0 miles. It's kind of like a starting point. It's not always going to be 0, 0. And then the last thing would be using the equation that I already found. In 2013, the asteroid was 17,200 miles away from Earth, if the asteroid made a turn and came straight towards the Earth, how long does it take the asteroid to travel that distance? How much warning would you have?
So that's divided by 5.
Hold on. X and Y, 17,200 miles. Is that X or Y? Look up here. It's miles is Y, so I'm going to put 17,200 in the Y spot. And we're trying to find how long, so that's the X, the seconds. So we're trying to solve for X. How do we get X by itself?
Multiply by 5, 40.
Okay, so you can do that in one step. I'm going to pretend that that's harder for some people, so you can also divide or multiply by 5 first, but you can do it in one step if you want. Multiply by 5 first, and I get 86,000. It's 24x. And then divide by, yep, it is a decimal, 24.
3, 5, 8, 3.
Let's do an approximation. 3, 5, what? 8, 3?
Yeah. 23.
Right. So we'll just that 0.3 of a second is not going to matter to us. So we'll say that. So if I said, oh my gosh, guys, there's a asteroid coming and it's going to be here in 3,583 seconds.
Well,
Would you really know what that means?
yes. Yes, it means it'll be here in 3,583 seconds.
Yeah. Do you have an idea of how long that is?
2 hours?
Well, let's calculate that.
Let's find out how we can do that. What would you do to change this into minutes?
That's just under an hour, because 60 times 60 is
21,000 minutes. No, wait, 240.
just under an hour.
Wait, no. I said in
So it's 1
multiply.
minute under an hour.
Yes.
Yeah.
59.
So it's 59.7 seconds, so it's about 1 hour. So if I said, oh guys, we've got 3,583 seconds before the asteroid hits, or if I said there's 1 hour before the asteroid hits, it makes more sense to say the hour. So
I think seconds.
that's not how I would talk. All right, second one, same kind of stuff. I've done a lot of the work already, except for I forgot the equation of the line. I'm going to throw that in there. I had to do that last bill. Forgot to put that in there. Put that equation of the line real fast right here. Okay. So in this situation, we have a car loan, and which is a real life application for a lot of us. Someday you might have a car loan as well. At the bottom, the X says number of payments. On the Y-axis would be the balance, and it says in thousands of dollars. So this is not 12. This is 12,000. But the number of payments are like 1, 2, 3, 4, 5, 6, 10, 20. But it does also say up here in the directions that it's monthly payments. So it's like paying per month. So when you see 10 payments, that's not 10 years, that's 10 months. So I found the slope, I got -3/10. That means the balance of the loan is decreasing by $3,000 every 10 payments. Well, we're going to simplify that slope and make it say something per month, per 1 month. So what's happening to the loan? Loan decreases. How much per month? How can we find it out? Divide what by 10? 3,000? Because that 3 over 10 is actually 3,000. So we're decreasing $300 per month. And I would say that seems like a reasonable loan payment. If you got an answer like $30 per month, I'm pretty sure you're wrong, because there are not many loan payments that are going to be $30 per month for a car. Okay. All right. Was there a question?
It used to be negative for them.
Yeah, that's the word decreases. So we're interpreting. We don't say -300. We say it goes down by, right? That's our interpretation in words. So the interpretation is always words. We're going to interpret the y-intercept. So that one's different than the previous one. Here's our y-intercept at 0.18. What does that mean?
Means for 0 months, or for 0 months, there is $18,000.
At 0 months, the balance of the loan is $18,000.
That's a whole lot.
Your car could have been $30,000 and you brought $12,000 up front and then got a loan for the rest of the $18,000. That doesn't mean that's how much the car costs, but maybe the car was exactly $18,000. This is just how much you got a loan for. And then found the equation of the line. What is the remaining balance after 36 payments? I don't know why I wrote it down there so far. The remaining balance after 36 payments. So we're going to have to use this equation of the line. We're going to have to plug in 36 somewhere. But why is it x?
Because you're trying to find
Well, we're going to use this here, and we're going to look, x is the number of payments, and this says number of payments, right? So, and then y is the money, so we're going to find y. So y equals negative 3/10 times 36 plus 18, and you guys calculate that. What?
I got 7.2.
You should get 7.2. But let's interpret that. I just got a number. What does that actually mean?
72 dollars. Oh my God.
What did the 18 mean?
I got 7.2.
What did the 18 mean? $18,000. So what's the 7.2 mean?
$70,200.
That means after 36 payments, 3 years, you still owe $7,200 on that loan.
When you talk about that much money, do you say 7,200 or 7,200? Just like your preference.
I do 7,200. But I don't assume everybody does the same thing. So. Yes, all right. Next page.
Jay, you want to
I'm going to summarize what it talks about in the paragraph. If you guys are on the prom committee and you're trying to find a place to host prom, and Savannah Center was booked, so we're going to look other places. So there's 2 options that you found information about. There was the Lakeside Inn, where they gave you a breakdown. If you have this many students, it costs this much, or this many students cost this much, or this many students cost this much. And then you went to the Sunview Inn, and they're like, oh, here's our mathematical equation of how we calculate how much it costs by the number of students. But you're like, oh no, I can't compare numbers to equations. So what you do is you take this information and you find the equation, which I already did for you. And the equation is y equals 12x plus 300. And you take this information and we also find a breakdown of numbers. Okay? So that's what I did for both of them. I already did that part. We're going to interpret the slope and interpret the y-intercept for each of these. So if we look at y equals 12x plus 300, our slope is 12. What does that mean?
For every 12 students.
No, what's x talk about? X is the number of students.
So multiply by the number of students.
12 times the number of students plus 300 is y, the total cost. Remember, our slope is the change in y over the change in x, which I wrote on the other side, and our y value has to do with cost, and our x values have to do with number of students. So when you interpret, you write something about cost per student. So if I look at the 12, what does that interpret to be? No, what's the top number have to do with? So I can make this into a fraction if it helps. 12 over 1. Now it's a fraction. It's $12 per one student. That's our rate. That's what they charge, $12 per student. How about the slope for Sunview Inn? M is 10. What does that tell us?
For every 10 students.
Nope. The top number is the y cost. So we talk about 10 being the cost. The bottom number is the x values, the students. So this is $10 per student.
Well, I thought X was the student.
It is. And y over x is our slope. How many students do I have right now? 1. So I'm doing $10 per one student. So when we talk about rates, when we talk about real life application, we talk about usually per one student, like the number 1 on the bottom. Okay, we're going to interpret the y-intercept of this as well. So we look at the y-intercept, it's this second part, 300, that's the y-intercept. So 0, 300 would be the point on the graph. What does that mean? Remember, no, what's y have to do with? Money. It's just $300 at the place, even if nobody comes. Well, that's an opinion. So it's $300. Oops, $300 just to rent the venue or place with no students. With no students. So how about the Sunview Inn? What's 0, 600 mean? Y is money. So this is $600 just to rent the place with no students.
I think the other one's cheaper.
Always?
Well, no, because if there's a certain amount of students.
Because like
No,
even if
because
the
it's
story
$300
something costs
just the
more,
market.
it
Just
actually
because
costs
of-
less than 6. I don't know.
Saying good things. I was letting you talk.
Oh, okay. I just looked at it so awkwardly.
I'm sorry, that's my face.
Remember she said she didn't.
I do. I can't control what it looks like. Let me try it again. Keep it.
Wait, what?
I'm going to try to not look awkward.
Now it's more awkward.
Okay. Okay, so we can argue, or we can decide which one is better by looking at real data. Look at my breakdowns.
Break it down.
I already did.
Yeah, they're really just-
It depends how many students. What if we have 100 students? Who's the better deal? Lakeside Inn. What if we have 200 students? Who's the better deal? Sunview Inn. Because Lakeside's charging more per student, even though it starts lower, it's eventually going to pass the Sunview because it has a higher rate.
Is that what you mean cheaper is not really better?
Yeah. No, when I said, somebody said 300, oh, that's not expensive, and somebody else said, oh, that is expensive. Like $300 is a number that you can't define as expensive because it depends what money you're used to seeing. You know, like if somebody's buying $300 pair of shoes every other day, 300 is probably not that expensive to them. Where I haven't bought new shoes and I bought from the kids section last time.
What size shoe do you wear?
Apparently I wear 6 in kids. Oh, no, I know. I went with
That's different. You can't-
one more to interpret here. Okay, we're just going to go to the next one. Let's go to the graphing calculator part. Okay. Because I want to spend more on the graphing calculator part. And in my first class, I did record the last question. So if you want to see it, I did record it. Okay. If you don't have a graphing calculator today, A, take notes. B, rewatch the video. You can try Desmos, but I'm not teaching you how to do all this stuff in Desmos while I'm teaching the graphing calculator at the same time. So if you don't have a calculator to use on your own, you have to have one for this class. Sent out an email before school even started. If you don't have one, you got to get with the program like ASAP. Okay. Using a graphing calculator. So what I'm going to do is I'm going to talk through these steps, and I'm going to show you how to do it. And then if you guys get an error, like stop me immediately so I can troubleshoot right away. But this does not say everything I'm going to say on here. So if you need to learn how to do it, you're going to need to rewatch this video or watch somebody's video, because there are videos out there. The first thing we're going to do, well, let's look at the data. The data talks about the length of a femur, which is the longest bone in your body and your leg, and compared to the height of a person. Okay? Do you just think that if I know the length of a femur, that might determine how tall a person is? If I told you, let me rephrase what I'm saying. If I have a really small femur, what do you think that determines about the height of a person?
Short.
So it does determine how big a person is.
Well, no, because you can be really tall, like mostly up here, though.
No, and you are right. It's not going to be 100% exact, but we can closely predict. It's not going to be like, you know what? I think if you were born in January, you are this height, or if you're born in December, then you're much taller. Do you think that really correlates?
No.
Yeah, it has nothing to do with what month you're born in, but how long your femur is does have to do with how tall you are, because you're not going to have somebody walking around.
Why should do the same thing?
I've seen you.
Someone just like take a picture.
Okay, but there is a proportionality thing, but at the same time, it's not that ridiculous.
No, that looks good.
Now I see what you're doing there. Good job.
No, one day. This makes me think SpongeBob. Will take a picture. Now she's just having all what?
Okay,
You know what? I'm just gonna draw this up.
let's learn how to do it. First thing is we are doing statistics. We're doing statistics. So you're going to go to the stat button. And actually, before we even start, clear everything. Go to y equals and make sure there's nothing typed in your y equals before we start. Okay? Y equals. Okay, and there's something else that we're going to do before we start. And this next thing that we do before we start, we don't have to do every single time. We just have to do it once. So it's on the video. If you didn't bring your calculator today, it's on the video. But those of you that do it right now, you're not going to have to do it again. You're going to go second, and then you're going to choose the 0, which is catalog, and a big list is going to come up.
Oh,
Then you're going to hit the button that says x to the -1, which takes you to the D's. And then you're going to scroll down in the D's. Nope. Diagnostic on. Once you find diagnostic on, you're going to enter.
You hit enter, and then it says done.
And it says done.
Mine doesn't say done.
Then hit enter again.
Oh, I found it.
Wow.
Okay. Yep. Second catalog, which is 0. And then you're going to hit the button that has a D above it, which is x to the -1 power under the math button. And it'll just jump to the D's. And then arrow down until you find diagnostic on. You enter, and then you enter. And it says done.
Wow.
Can we go on?
Keep pressing enter. It keeps saying.
So now,
Oh.
I'm going to go to stat. Now we are starting it for real. Gonna go to stat. This is where you do all statistics stuff. You go to stat, and we need to edit. And there might be numbers in here already. Maybe you've done it before. Maybe you bought your calculator off of somebody. If there's numbers, you go up, you hit clear, you hit enter, and it clears the list. If there's not numbers in here, you're going to have to do this later. You might have to go to my video and watch this little part again.
What do you do when you get static?
Edit.
Oh,
And then you go up to the L1 and you hit clear, enter, and it clears everything in there. But there will be stuff in there after this, so you're going to have to do that on your next, time that you use your calculator. So now we're going to type in all our X's, and you just type in 40, enter, 45, enter, and just type in the whole list of X's. Talk. What? No?
No, my bad.
Okay.
No. Never mind.
And then after you type in your X's, you go over to L2 and you type in Y. And you enter between each Y that you type in. When you are done, there should be like 45 and 182 matching up at the bottom. They shouldn't have like one column longer than the other, because then you're going to get an error. What? No, I'm just giving enough time to have typed it in. Okay, once you've typed in your statistics, now we're going to graph it. Okay? So you're going to go, so this isn't an equation. These are to statistics. These are points on a scatter plot. So instead of graphing y equals, we don't have an equation. So instead of graphing y equals, we're going to go above it where it says stat plot, second stat plot, right. And we need to turn it on. So to do that, you hit enter. And you're going to, I think everybody has the same thing. You hit enter again. And then you have to choose the type. Make sure we have the scatter plot chosen, otherwise it's going to look different. Your X list has to be L1. Your Y list has to be L2. Your mark, that I don't care which one you choose. If you have colors, I don't care what color you choose. But after that, you're going to hit graph. And you guys are going to tell me nothing showed up.
Because you have to change the zoom.
We have to change our window. Okay, so if nothing shows up, it's because right now we've got like 10 by 10 and negative 10 and negative 10. But if you look at the femur and the height, they don't fit. So we're going to go to our window, and we're going to adjust our window to match our data. But there's some data on here. There's some data that you have to keep in mind that might not be in your table. What, Keenan? Okay, I'm going to come right there.
Yeah, mine said error.
When you hit window or when you hit graph?
I heard graph. It was like error.
Okay. Quit that. Go to window. Let's fix our window first, and then I'll help you. Let's fix our window first, then I can help you with the error. Somebody poke him.
You got the egg?
I'm still awake.
No.
Yeah, no, I'm still awake.
What should I put on Windows as? Oh, no, I'm there. What's in the egg?
Okay. What is the smallest femur we could possibly have? You're not where we are. You're worse than me. Nope. What's the smallest femur?
32.
30. I'm not talking about in this table.
0.
0.
Oh, Annan, you're so smart.
You could not have a femur.
Never seen.
Could we have a negative length for a femur?
We can totally.
Am I still recording?
Yeah.
No, it says pause. 5. Okay. Okay, so the smallest femur we could possibly have would be 0. You cannot have a negative femur. On this table, it looks like the tallest one or the longest one is 50, but let's give it some extra. How about 60? And then what do you want to count by? That is up to you. I'm going to count by 5s. You can choose ones if you want. The Y minimum, that's my height. So what's the smallest height we could have? 0. We can't have negatives. Then on here, it looks like the highest is at 195, so 200. Sounds good. And then the scale, I'm going to do 10s. You can do 5s, that's fine. It does not matter. Our scales don't have to match. And now when we hit graph, we will see the scatter plot. It didn't show the first time because of our window.
Mine's not here.
Mark put me on. Yeah.
Okay, so those of you that have that are having trouble now, this is where either your partner can troubleshoot or who else? Oh, two.
I was sleeping, so I was waiting for the next directions, and we were talking about nothing. We were standing on the window for like 5 minutes.
Have you ever turned on
Jake,
the
where'd you
scatter
find
plot?
that?
So you go second,
Yeah, calm down.
I had it as paper.
and you're
Calm down.
That's fine.
When we went to turn on the scatter plot, you didn't turn it on. Second what equals?
I like how you answer to the word softball.
Who else?
Why is yours a flower? She's so flower.
Okay, when you typed it in originally,
You can have one after.
oh, I can fix
His is
that.
fit your family on the graphic. I'll do
But
it.
for right now. Because I'm looking for information.
Oh, I can't wait to go home.
It's so funny.
I know.
How you say that?
This is Chris Wells.
What if-
I am trying to troubleshoot everybody.
Whoa.
Select a stat, edit, and one of the numbers you put in, I can see it.
Oh, trust me.
So if you fix that one and then you hit graph again, it'll fix it.
Has anyone found your egg yet?
Yes. Okay. From here, I'm now going to show you how to find the line of regression, which is the line of best fit.
I remember this.
So you go to stat. You don't remember what it means?
Oh, and isn't it where like you cut the data like
It's like the average. The average, yeah. So you're going to go to stat, and this time we already have our stuff put in, so this time we're going to calculate something. So you're going to go over to calc,
line reg?
and linear regression is number 4. Do one further down. Linear regression, linreg, number 4, line reg, number 4. And then AJ, when we do this, because your L2 is missing, you have to change that to an L3. And if it doesn't change it, I can troubleshoot you. Okay, but since my stuff is in L1 and L2, I'm just going to hit enter a bunch of times till I hit enter on calculate, and it will tell me all this amazing information. Enter, 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 enter. Stat, calc, 4, enter, 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 enter. Got it. Okay. This answer is written here. You don't have to write it down because it is written right here. This equation of the line is y equals 2.6x plus 20 or plus 65. So 2.6 would be the slope. 65 would be the y-intercept. And in your assignment, you're going to have to interpret that meaning.
We're going to have to do this, or
That's why we're making a video. Okay. There's something else called the correlation coefficient, which it talks about up here at the top. I skipped over that. It talks about it there. It's basically telling us how close this data is being a perfect line. It's telling us, is this data good data to use to predict for other people? And how you know that it's close to being a perfect line is if the R number, the is close to being 1 or close to being -1. It does say that in the directions, but I'll just write it here. If it is close to being 1 or close to being -1, it's a strong correlation. If we graphed, which we can do for fun someday, if we graphed your birthday month compared to your height, there should be no correlation. Okay, there should not be a correlation if we graph birthday compared to height. What? Is somebody helping him?
I have a question.
Yeah.
After I did like the enter thing, I got the Y equals M equals B and the A and the B.
But you didn't get your R's.
Yeah.
Remember we did diagnostic on.
Okay.
Did you do that with us? That's what turns it on. Okay? So I can come help you fix that, but I'm going to show you how to do. You don't need that for the next thing we do, but you do need it for homework. Okay. All right. So then the last thing I'm going to show you how to do is take this information and graph it. So this is the line of best fit. This is a good line to predict other heights of people if you know their femur length. So we are going to use this and we're going to graph it. So to do this, the easiest, quickest way and the most accurate way is you're going to first go to y equals. What? Okay. So we're going to first go to y equals. Already cleared stuff out of there. So you have to tell your calculator, this is where I'm going to put the equation, but you don't actually have to type it in. We're just going to copy and paste it.
That's
So-
how I do all my. Oh wait, that's not.
Okay. To copy and paste it is weird. So you either write it down or you go back and watch this video or maybe magically remember it. I've had to look it up in the past. I remember this year though, so that's good. VARS is the button next to clear, I guess. VARS you go to first, VARS. And then we choose 5, which is statistics. That's what we're setting, 5.
Whoa.
And then we go over to EQ, which stands for equation.
Right.
And then you do the regular equation, right? And it copies it there for you. So again, that was VARS, statistics, EQ, reg EQ. And then it's copied, and you can hit graph.
And then it shows up. That's so cool.
It's a nice scatter plot. There are no outliers.
I see this as an absolute win.
There's no outliers in the scatter plot.
Equation
Right, because it's really close to being a perfect line. It just depends on the information and data that you're given if there's outlying points. I have one more thing that has to be recorded. And that is this part right here. It says estimate the height of a person whose femur is 35 centimeters long.
But don't you just plug it into like the arc tutor or something?
Nope. Well, you could use the equation and plug it in, but I'm going to show you how to do it. If you do second trace, which is calculate, and you choose the first one, value, it says, what do you want x to equal? And you go, oh, well, I want x to equal 35. And it tells you the answer.
35, 156.1.
156 would be the height of the person. What's 156 what?
Trace them one.
I'm guessing it's centimeters. Second trace value.
All right.
35 enter. You can also use your table if you don't remember that.
I don't think I can remember.
If you go second, oh, that's why there's a video. Second graph, you can go and find anything in your table as well. So you could go and find any values in your table as well. People who knew how to do the math in the first place. And coding on top of it. So I'm going to stop the video here. The assignment is 4 questions on a worksheet. You have to do this stuff, and then you're going to also have to interpret slope and interpret
What was it?
y-intercept.
Just like say like what it means.
It means like right and